Welcome grade 12s. Today we are moving on in our Loki cams. We did simple harmonic motions yesterday and the day before, so today we are going to be doing uniform acceleration and retardation. It's really simple, but let's learn. At the end of this lesson, you will be able to recognize when to use uniform acceleration and retardation in cams, and also how to draw a displacement graph representing uniform acceleration and retardation. When to use uniform acceleration and retardation. You will be told in your instructions under the motion subheading. It will say the follower rises or falls or returns for X millimeters with uniform acceleration and retardation. Or it will split the motion into two. Then it will say the follower rises X millimeters with uniform acceleration. As a separate point to the follower falls or returns X millimeters with uniform retardation. We are using pages 10.8 and 10.9 from your HSC grade 12 workbooks for reference. Ignore the instructions for simple harmonic motion because we did that in the last lessons. Scan the QR code to get them. Step 1. You start off with drawing your displacement graph and dividing the height of the graph into the number of divisions you need to complete the motion. You must first identify how many divisions you need to make. On page 10.8 we need 6 divisions and 10.9 we need 8 divisions. So how do we know how many divisions we need? This is because in 10.8 the motion goes over 6 spaces in the displacement graph. It starts at 180 and ends at 360. And in 10.9 the motion goes over 8 spaces in the displacement graph. It starts at 120 and ends at 360. As a refresher, there are 2 ways you can divide your graph. You can draw a line at any angle, mark off equal divisions, then project the last division to the top of the graph and keep that angle as you work your way down. Or you can use your ruler, place the 0 on the bottom of the graph and position the number of divisions you need on the top of the graph. Then make markings at every centimeter. Those are the 2 ways to make equal divisions on your graph. So here on my slide you can see that the top one is the division of the line at any angle, and then the second one shows you the ruler method. So here are the working drawings of the line division. On the left is 10.8's displacement graph that I use line at any angle method to divide the heights of the graph. And on the right is 10.9's displacement graph where I use the ruler method. Step 2. So what's next is we need to project the division lines you just created toward the middle of the motion. So you'll draw the division line onto the degrees line that goes vertical that represents the middle of the motion. In 10.8 the middle point is at 270 degrees. In 10.9 the middle point is at 240 degrees. Here is the line to the middle of the motion examples. On left is the same for 10.8. I projected the division markings to the middle of the motion at 270 degrees on my displacement graph. On the right is 10.9's example. I projected the markings I made to the middle of the motion, which is 240 degrees. Step 3. Construction lines. From the points where the lines you just projected to the middle of the motion intersect with the vertical degree line on the displacement graph, draw a construction line to either the start or the end of the motion. In 10.8, the top 3 lines are drawn to the start of the motion at 180 degrees, and the bottom 3 lines are drawn to the end of the motion 360 degrees. In 10.9, the top 4 lines are drawn to the start of the motion at 120 degrees, and the bottom 4 lines are drawn to the end of the motion at 360 degrees. Here are the examples for the construction lines to plot the graph points. On the left you can see 10.8's example, where I took the top 3 lines to the start of the motion at 270 degrees, and I took the bottom 3 to the end of the motion at 360 degrees. And on the right hand side is 10.9's example, where I took the top 4 to the start of the motion at 240 degrees, and I took the bottom 4 to the end of the motion at 360 degrees. Step 4. Plotting graph points. So where the top line that you just drew and the first vertical degree line after the start of the motion intersect, plot that as your first point on the uniform acceleration and retardation graph. Then where the second line that you drew and the second vertical degree line after the start of the motion intersect, plot that as your second point on the uniform acceleration and retardation graph. Continue this pattern until all the plots are done. Here are the examples of the graph plots. On the left is page 10.8's graph plots, and on the right is page 10.9's graph plots. Step 5. Drawing your graph. So connect the points that you've just plotted either freehand or with a flexicurve and you have your graph. Then follow the rest of the recipe, project those lines to your follower, and draw your cam profile as normal. Here are the two examples of the graphs. On the left is page 10.8's graph, and on the right is page 10.9's graph. Okay, now it's your turn. So complete page 10.8 and 10.9 in your workbooks, and have fun!